Hello and welcome to my video on computational strategies for multiplication. I'm Mrs. Dylan Vogrig, and I'm going to start with some estimates. So I'm working with 17 times 24, and I want to round that up to a friendly number. But you know what? 20 times 25 was still too hard for my brain, so I went with 20 times 20 and got 400. And then I checked my work by doing some really quick math. Then I decided to see if I was close by working out the problem using this manipulative in a concrete strategy. In this case, I'm using these cardboard pieces that I made. The orange and red are tens, and the purple are ones, and the green are 100s. And I've made groups of 24, 17 groups of 24 out of the tens and the ones, and now you can see I've actually started trading in my ones for tens because it's easier to see how many ones I can trade when they're all laid out. And now I'm trading in tens for 100s, and slowly this simplifies the number and helps me find the answer or product of multiplication. And so now we see that we have 4 100s and 8 ones equaling 408. So I was pretty close with my guess of 400, but let's try again with a pictorial example. This time using the same colors just so that my brain can keep up with the different ways of expressing these numbers and values. So we've got ones in purple again, the tens in orange, and you can see that I'm doing the same process where I'm trading and exchanging these values to get the greater value of the sum. And now I've got, again, those 4 100s and the 8 ones left. And now I'm going to do some Japanese multiplication. So this is really cool. I've done 1 line and 7 lines and 2 lines and 4 lines representing 17 and 24. Now where they meet, I'm going to highlight and section these groups off to identify different place values, which we'll look at after. But first I'm going to add up all of the little points in each group. And there were lots of them, and so I'm going to have to carry a number. So I'm going to have to carry this 2 and make this 18 into a 20, but I'm actually going to have to carry that 2 again, so that'll be a 0, and then the 2 will turn into a 4. And then when we look at this, we can actually see we've got 408 again, and we can see how the 8 is in the ones place, the 0 is in the tens place, and the 4 is in the hundreds place. And I've shown you these groups with these colors again because this is just how my brain works. It really helps me to have yet another visual representation to tie it all together. So now let's do some symbolic strategies, starting with this one, which is an array. This is really helpful for me to break up the number 17 into a 10 and a 7. And now I'm just doing multiplication. For example, the 1 with the 2 and then adding the 2 zeros for 10 times 20 and so on. Getting these different products of each quadrant of the array, and then I add all of those together to get 408. And then I can actually write this in a formula as well. And actually both this formula and the array, which I can refer back to help me put it together, reflect the concrete and pictorial because it's grouping these values in these friendlier numbers. So we've got 17 4s, but it's broken into 10 and 7. Or we've got 24 7s, but it's broken into 20 and 4. Demonstrating all of these different strategies, the concrete, pictorial, and symbolic, is to show you that multiplication really is no big deal, and there's a strategy for everybody. Thanks for watching!